Hello, everyone. It's great to be back at YOW. Today, I want to talk about software design and more than just the usual boxes and lines that we draw in every architecture diagram. I really want to get at, one, what makes software design so important and powerful? And two, how do we do it better and better? How do we get really good at it? To do that, I'm going to do a little whirlwind tour through a bunch of modern software movements. And then I'm going to get at a few principles that I think underlie a lot of these. And then the most important one, and then why that's important. Spoiler, the answer to both questions is software design is participatory sense making. What the heck is that? Let's start by doing an example of participatory sense making. It's time to have an activity. Maybe. There we go. Okay. In this meeting, we are all here because we work for the Frobozz Magic Fantastical Creature Company. And Frobozz Magic, as you all know, the Fantastical Creature Company specifically, we serve the owners of castles, of fantastical, wonderful castles full of treasure. And they need to protect these castles from all these pesky adventurers who are always climbing up the mountain to raid this castle for its treasure. We produce the fantastical creatures that can defend your castle. Now, any old fantastical creature company can sell you a wyvern or a griffin or something right off the shelf. Our specialty is brand new fantastical creatures. So we're here today to kick off Project Chimera. And we collectively, we are going to make the next fantastical creature, and it's going to be magnificent. We need feathers and fur, and it'll be fast because we'll have hooves and wings. And also it needs to be menacing and frighten off those adventurers. So we need some fierce claws and some horns. All right. So together, today, we're going to come up with what is this fantastical creature, and we're going to get like our models in sync so that we can work together on it. First of all, you need to know how we produce this creature, and to remind you all, our creatures are produced in a cloud over a bubbling cauldron, and our spellcasters will put in the ingredients and they'll utter the incantations and stir it just so. And then the creature will be summoned and morph into the most fantastical, magnificent, menacing creature that we can produce. Okay, but what creature are we producing today? Because this creature is entirely new in the world, it takes some work to get together on that. Put in the chat whatever you are thinking in the stage chat. Put what you think a creature needs for movement, magnificence, and menace. And in the meantime, here in the Miro board, we're about 25 seconds ahead of you, by the way. I've got Michelle and Gretchen and Ino here, and they've already pasted in their ideas. And I have a drawing here of what this creature might be. Okay, so I'll watch the chat to see what you all think. Michelle, Gretchen, I know if you could like circle your favorite parts of the creatures or something, that could help. I'm looking at these and wow, Ino's has like this great like fluid form. You can really see the movement in that one. Let's see. So wow, oh yeah, okay. So there's a favorite part is like the hooves and the claws. You know, I also really like, the tail, the cute tail, nice. Oh, and the nice wings. I agree. You know, I really like the body here. Okay, and the tail. Let's see if we can pull the wing off of Gretchen's creature here. And maybe we'll put this on, so we'll have the wings. Okay, let's see, John says it needs a persuasive voice, talons. Ooh, big muscles and horns. Kyle says our creature needs a 6 stereo. If anybody can like paste one of those in the board real quick, I am on board with that. This did not work. Come here, Windows. Give me this wing. All right, my screen capture is just not working. Thanks, Miro. Crop. We're going to get this wing, dang it. There we go. Okay, we've got this wing. Oh yeah, look at those talons on Michelle's creature. Let's grab those. We'll just get something from each of those with a crop. Peter suggests more than one head. I love it. Okay, here's some good talons. Well, we can always have more talons. They can have multiple talons. Okay, the talons in the skirt is going on. Oh, yes, thank you. That's perfect. Whoops. Okay, so we've got a 6 stereo now. Let's put that in its talons, maybe. Bring to front. There we go. Okay, and more than one head. Aha. Let's see if I can. Miro, are you going to work for this? You might work. See if I can add this head. Yes. We'll have that head and this head. We'll just put it right on the back. Oh, there. Boom. Okay, we've got 2 heads. We've got a couple different wings. This is fun. We've got that long tail. We've got those hooves. We've got something from everything. Self-regenerative skin. Ooh, that's good. Maybe we can add that later. Bow and arrow. Oh, that would be cool. All right, but I'm going to stop here for now. And we've got a good list of features in the chat as well. Oh, a cool name. Ben remarks that it needs a cool name. I agree. I mean, y'all can put in chat what you think we should call this name. In the end, marketing is going to have the final say. But for now, before they've completed their decisions, a monocle, that would be awesome. Let me add a monocle real quick. We can just do that with this. There, a monocle. Here's its little chain. All right. Great. Okay, so now we have this. Let's see, I can group this together. Miro, give me what I want. I can group this together. And here's our creature so far. What do we think it should be? Craig. Adam suggests Craig as a name. Anyone else? Oops, I did not mean to. Oops, what did I just do? Group. There it goes. All right. Here's our creature so far. And we're going to put it in this spot above the boiling cauldron. And this is what we're summoning so far. Ooh, oh, okay. Okay. Michael Perry just said Captain Rower. Captain Rower. There it is. Let's pick an obnoxious font. There it is. Okay. So we've got Captain Rower here. That's our latest creature. I'm sure marketing will change it and make it something incredibly less interesting and accurate. No, Michelle, we're not going with Creature McCreature Face, but that it had to be suggested. All right. All right. So together we have collectively pooled our ideas and we've created a shared idea of what creature we're making. Thank you for participating in this particular sense making exercise. Next, we're going to move on to the process of creating this creature. Because there's a lot of capabilities inside our Frobozz Magic Fantastical Creature Company that are necessary to supply these creatures to customers. So let's make a value chain diagram. A value chain diagram, let's see, we'll start with the customer. So here's our head of security of castles up here. He's got a badge. That's a star. That's a badge, trust me. And he needs creatures. And in order to supply our customers with creatures, well, let's see. We know we need spellcasters. Talked about that. And then let's see, those spellcasters are going to need, cauldrons. Perfect. We need that. Let me connect these up with some arrows. Creatures need spellcasters. Spellcasters need cauldrons. Oh, a dungeon. Okay, so we'll need a dungeon to put in the spellcasters. Anybody can throw stuff in the chat that we need. Also, Michelle and Gretchen, and I know you can put stuff in here. Ooh, Eye of Newt. Okay, that falls under ingredient supply, right? Oh, wizard hats and robes. Okay, we're gonna need those. And we're gonna need ingredients. And the ingredient supply will need Eye of Newt and Leg of Toad. Creature handlers. Okay, the spellcasters don't need those, but in order to produce creatures, we totally need creature handlers. Ooh, Tome of Spells. Yeah, that's needed by the spell. Whoops. Spellcasters just got big. That's fine. That can be big. Right. What else do we need? Cages. Oh, the creature handlers are going to need cages. That's the thing. What's up here? Spell writers. Okay, this one I'm going to make big. Spell writers will need a Tome of Spells, and wands. Oh, good one. Great. Oh, Josh suggests a fire. Yeah, for bubbling cauldron, we need fire. Oh, okay. Well, that got a cool font, whatever. Cool. we clearly need the 6 stereo. Actually, that's a good point, that this stereo, a creature operating stereo, is not something that we've had before. In fact, so our creature, this particular creature, is going to need the stereo. And so that is a new capability that our company is going to have to develop. So let's like highlight that. Let's make it blue or something. Okay. Now that we have a value map, a value stream map, no, we don't have a map. We have a value stream diagram, but I want to make it into a map. Now, the difference between a diagram and a map is that in a map, placement on the page has meaning. Whereas here, if I move the stereo over here, it's the same diagram. The connections are the same. The boxes and lines are equivalent no matter where you put the boxes. We just arrange them for our own aesthetics. In a map, location does have meaning. So in particular, we're going to make this into a Wordly map. And a Wordly map, the 2 axes, there's an X and Y axis, they have, they commonly use the meanings of vertical is visibility. So visibility to the customer. The customer's at the top, the creatures are very visible, the stereo, that's going to be pretty visible. Maybe we give tours of the dungeons. So the dungeons are pretty visible, and the spellcasters, they'll see that. Whereas ingredient supply, far behind the scene, the spell writers, they do not, we do not show anybody our spell writers. And we also don't give them access to the Tome of Spells, although they do know it's there. They'll see the wands, those can go up pretty high. QA warriors. Yeah, our spell writers will need QA. They'll need like adventurers to test out. And test castles. Good call. We'll need a test environment for our spell writers, but that's all very behind the scenes, so it's kind of low. The horizontal axis, though, is more interesting. Get bigger. The horizontal axis, please moves over here. There it goes. All right. Is about how standardized each thing is. And you particularly want to talk about how standardized it is in the industry, not just in our company. Okay, so like Leg of Toad, probably a pretty standard ingredient. Cages, very standard. We can totally buy those. Creature handlers, we need our own creature handlers for our own creatures. We can't just use somebody else's creatures handler that's used to handling ordinary wyverns and griffins. Our spellcasters are definitely ours, but the dungeons, we can rent dungeons. That can be someone else's product. Bubbling cauldron, those are pretty standard, but maybe we make our own fire. Just whoops. Okay, that's just not moving. Ingredient supply, maybe there's an industry standard ingredient supply, but we happen to have our own. That one could be somewhere in between. The important bit is there's a lot of custom stuff that we need specifically. We need these capabilities. We need our own Tome of Spells, maybe because it's fatter than the standard ones, and our own creature handlers. But anything that is standard goes in someone else's product, and stuff that's like super standardized might be a utility. Maybe dungeons are just dime a dozen. Everybody uses the same ones. On the other side, all the way over to the left, we have very few things. And this is where you put your secret sauce. This is the stuff that makes our company different from every other company. This is what we're iterating on and continually getting better at. And in our case, it is the spell writers, because these are brand new spells that do not exist. We need to constantly iterate on these spells because that's what's going to make these creatures great. That's what makes them unique. That's what makes our company money. The stereo, also different. Now, I am going to say that it's going to be new to our company, but we might be able to source the stereos. So we'll put them over there, but we're going to have to develop that new. These spell writers, however, are over in the Genesis column because that's where we want our most agile team, are like really constantly learning, moving quickly bit. Wordly maps in general, I mean, they're never complete. They don't so much tell you how your company works as open a discussion. Wands, for instance, if we're making custom wands, by now the industry standard for wands has probably advanced. In general, things move to the right over time as more people need them, and we can probably buy wands and save money while getting something better. Because I'm sorry, if I have to use your internal software that has existed longer than Google Calendar, but is not better than something I can get for free at home, we're not helping ourselves. Okay, may have been burned by that recently. Right, so wordly maps, you can talk about like what is standard and what isn't and where we should move. But what matters to me about this concept is that it focuses me in on the capabilities that this business needs to do what it's going to do. That focus on capabilities makes a big difference because each of these capabilities is going to be supplied by a team. Maybe we have the same team supplying eye of newt and leg of toad. I don't know, but each capability will come from, in the end, one team, and it will come from one product team. So here's like one of the important movements in software today is the movement toward product teams as opposed to project teams. And the difference here is that product teams have a wider time span because they recognize that it's not just about delivering a feature. It's about providing a capability, and we need that capability ongoing. And it's not about a fixed time span. A project has a fixed time span and a scope. And then we resource it with people. And we call it a capital expenditure. And that has tax advantages, which is one reason it's so hard for the big enterprises to switch over to considering software an operating expense, to look at software as a capability that we need a stable team maintaining and constantly improving. But that's what a product team does. And a product team gets to do this building up of knowledge collectively of what the software is even for, how we can do it better, how that's going to work. And that knowledge makes them able to work smoothly and quickly and create much better software that people in the company actually want to use, that might actually be better than what's available outside. It's okay, Jess. Right, so product teams, one of the important modern movements. Team Topologies expresses a lot of this really well. If you haven't read this book, there's like 30 different books pictured in this presentation. If you only read one of them, let it be this one. Team Topologies calls these product teams stream-aligned teams because they're part of that value stream that's flowing to the customer. There's other team categories. There's like platform teams that kind of supply internal products to a bunch of streamlined teams, a couple other teams with specialized knowledge. But the biggest part of Team Topologies is that it recognizes that the limitation in how much we can accomplish, how many capabilities we can helpfully supply as a team, it's not time, it's not resources, it's knowledge. It's how much we can know. Because our job is not typing. You can tell because we don't type all day and most of what we type, we delete. Our job is making decisions. Yes, sometimes those decisions are what to type, but if we make those decisions well about what to put in the code now, then we won't have to do rework later. We won't spend all of our time debugging and doing hot fixes and arguing over which side of this interface was implemented wrong because it's suddenly broken in integration test. It's decision-making that is our job. And the fuel of that decision-making is our knowledge, is our understanding, our collective knowledge of what's going on in the company and in the software. And that's our limitation. It's cognitive load. And the limitation of how much software a team can support, how many capabilities we can supply, is the cognitive load required to understand all of that. That's when we start splitting up teams. And that's when we get to microservices, because microservices put those boundaries in the software. They say, we're going to keep the software small enough that it has a cognitive load level that can fit in one person or one team's head. That helps. In particular, it helps us establish deployment boundaries, which affect the rate of change. Because here's the thing, each of these capabilities that our business needs, each one needs a team. And when we're talking about software, that team needs its own deployable units, mainly in order to control the rate of change. Feature flags also help with this, because different capabilities need to change at different rate. Our spell writers are moving and learning very quickly. Our spellcasters are a little more stable. Our creature handlers don't change that quickly. So we need each team to be able to move at a different rate. And then the other thing that each capability needs is its own language and its own model of how the words and the parts fit together. So our spell writers really need a strong understanding of the process of how we summon the creature and then we transmogrify it to add features. And each of those features might be a part or a capability, or let's not reuse the word capability. Let's consciously choose ability, like speech. There were some other good ones in the chat, like playing music on operating the stereo. That is an ability that we need to transmogrify into the creature. And these are all the language that the spell writers need to be good at. But the language has to be specific to each capability. In domain-driven design, we call them bounded contexts, so that we can be specific about whose language is whose. For instance, spell writing is one domain, one bounded context. Spell casting is another. And the spell writers talk to the spellcasters, of course, to tell them what to do. They also both talk to ingredient supply. Now, the spell writers and the spellcasters, when they talk about an ingredient, they're talking about one specific thing like eye of newts or leg of toad and an amount. And that's what they need to know about an ingredient. And if they want to use a different ingredient instead, they'll delete that one and put in a new one. Whereas in ingredient supply, the word ingredient has a very different meaning. The word ingredient there includes like a supplier and a cost and a shipping mechanism and how long is it, what's its shelf life, and does it need refrigeration, and is it only available on a full moon? All of these things are part of the concept of ingredient in ingredient supply, but not in spell writing. Maybe in spellcasting, they need to care about the shelf life, but that's it. Bounded contexts let us use the same word in usually related but non-identical ways so that we can be very specific about what we're talking about. The model that the spell writers need of their work and of the creatures is specific to that domain. Now, what gets interesting is when you look at this particular circles and line thing is called a context map. When you look at this context map, each of these bounded contexts represents a language. But what about the lines? What about the lines in between? General rule of software design, by the way, we love to draw boxes and lines and we keep putting labels in the boxes. The lines are more interesting. put labels on the lines. What is going across the wire there? That's the messaging. That's the interaction. That's the relationship. That's the important part of these systems, not the parts. Parts are necessary. Relationships are key. So in this case, like between spell writing and spell casting, whose language gets used? Well, it turns out that the spell writers are like, they've all been spellcasters in the past. They're like higher level. So they'll use the language of this. No, wait, the other way. They'll use the language of the spellcasters. Undo. So the spellcasting language gets used on that pipe. And ingredient supply, man, the spell writers would love to be able to specify ingredients however they chose, but they've learned that if they want to get the right ingredient, they need to let ingredient supply dictate that language. And the same with the spellcasters. They're going to talk to the ingredient supply however they need it. However, ingredient supply is going to like work with it because they need what they need. The interesting part about looking at that, like looking at the different languages spoken between the bounded contexts, it says something about the power differentials between these different pieces. And now we get into something I've learned from feminism. Feminism says always look at the power differentials because that gives you the lay of the land in this particular territory and helps you make good decisions. In this case, you would think the spell writers would be more powerful since they're our secret sauce. But in fact, the ingredient supply people serve more than just the Frabas Magic Fantastical Creature Company. They serve the Frabas Magic Company, which like supplies directly to merchants, and they do not change quickly. In order for the spell writers to move quickly, they need to conform to the ingredient supply language and just give them what they need. Whoops, Control C, give me the pen. So they've built this little anti-corruption layer to decouple the language that they need to speak from the language that they use internally so that they can continue to do their participatory sense making and constantly improving their internal model and language and understanding of Captain Rar. Right. So these capabilities are really important. I think this is really core in understanding that we need these bounded contexts of knowledge to keep those separate and keep the cognitive load down. Another really important part about the language and model, the knowledge we're developing here is, whoops, I want this screen, is that it's built in collaboration with domain experts and strengthened using concrete scenarios. So we talk to the spellcasters. We also talk to the security guards of the castles and ask them about their experiences with it, with adventurers. We might learn that actually some of these are deployed inside castles and these wings just get in the way, and maybe we better make those wings an optional feature or make smaller wings like the cute ones on Michelle's creature maybe. Yeah. We build this model with the experts. That's how we get knowledge that isn't just stuff we made up. I mean, even at Honeycomb, we're developers making tools for developers, and we still have product people who do research on developers to find out what happens outside of our walls and really understand what's going on. Extreme programming, great. Extreme programming was one of the first movements to recognize this and get customers in the room. Test-driven development recognizes this because it asks us to be first users of the code we're writing and then implementers of that code. And this really helps us with understanding the code thoroughly. This is what test-driven development is really about. The automated tests are a happy side effect. Behavior-driven development also, again, this puts it in the business language and gives us really concrete examples. So if we show the castle security guard our scenario of, oh, some of these castles are underwater, we've learned that. Okay, well, we better be able to add a breathe underwater feature, transmogrify it to have some gills or something. And then we're going to put it in an aquarium and make sure it doesn't drown. And they're like, yeah, okay, it's good that it doesn't drown, but it also needs to fight. So maybe those wings need to turn into flippers. Maybe that stereo is not going to do so well, or do we need a waterproof stereo? That's going to be extra. Developing this language with domain experts helps a lot. And then, my favorite place to get concrete scenarios of things that happen is actual production. DevOps, of course, is crucial because it keeps the same people responsible for deployment, choosing that rate of change, and then also supporting that capability in production. And then observability, in my opinion, is the gift of DevOps to developers because it lets us learn what's really happening in our code. I mean, maybe it turns out that when our creatures are deployed inside, sometimes they bump into walls. Do we need to raise their intelligence or, I don't know, give them radar? Or maybe it's just that the talons are really bad on the floor. Concrete scenarios from production can teach us a lot. And developers are the best ones to get this information because we can turn around and change the code. And we can put this new knowledge to work. And that's the other crucial factor in this language and model in our bounded context is that it's not just in the people. It's not only in our heads, it's shared in our heads and in the code. And so in the running software. When we express this in the code, we get more rigor. The code provides us with that. And also, I mean, we make the model real in the world. Oh, and we solve one of the hardest problems in computer science, which is naming. Our job is making decisions, man. And one of the ones that trips us up is what to call this variable. What is this function called? If we look at this shared model and language development as an activity that's valuable in itself, and we do this consciously, then we don't get tripped up so much because we've already talked about, all right, when the creature has been summoned and we are going to transmogrify it to add a feature, we will call that transmogrify to having whatever the feature's name is. So maybe we'll call it, we're implementing breathe underwater, transmogrify to having gills, transmogrify to having a waterproof stereo. It helps. Of course, it's not going to tell us how to name everything because there are technical considerations to worry about. And that's where hexagonal architecture comes in. It lets us isolate our domain code that really expresses our model from some of the technical details, like talking to the database, talking to ingredient supply, talking to the UI. That domain code that contains our hard-won knowledge of what this creature really is, we want that to be side effect free, for instance. So we can use functional programming for that. That helps separate decisions from making them, test the decision making, test the implementation less because it takes longer and costs ingredients. But not just functional programming, object-oriented programming helps with this a lot too. It gives us good places to put names and organize our code and to recognize that immutability, I'm actually saying this, is not the best choice everywhere. Like the whole point of the summoned creature that is transmogrifying into a patented Captain Rar is that it changes. Maybe we want to model that change in an object. This is useful too. Everything is a process. Our creature is definitely a process. Oh, and it helps with security. When we're real consistent about our language, we get more secure code because the number 2 thing you can do for secure code is understand your data. You cannot validate your data until you understand each individual piece and what it means. What is a valid incantation? Can it contain pointy braces and JavaScript syntax? What happens if someone who's touring our dungeon yells out, delete all tables? Hopefully nothing, because we've accounted for that. For the record, the number 1 thing you can do for secure code is upgrade your libraries. Do that first. Number 2 is really understand what the meaning of each piece of data is. So we have these 3 principles, and you may recognize these because I pulled them out of domain-driven design. And this blue book by Eric Evans is really good. It's 15 years old. I mean, I recommend it, but I know you're not going to read it because it's really long and technical. I will say read the intro stuff and then skip ahead to the strategic stuff, because a lot of the stuff in the middle is actually a lot easier now that immutability is standard. It was new when he was writing the book. It was like, oh, you want me to what? I do that how in Java? Domain-driven design is the one movement in software right now that I think is at the forefront of meaningful qualitative improvement. That domain-driven design community now, I think, is what Agile used to be 15 or 20 years ago. It's innovative, and it's like got a very broad perspective and thinks really deeply about software design. Which leads to the question, while we're boiling things down, what's the one core essence of domain-driven design? That one's straightforward. It's the shared language. It's consciously developing and choosing to use our shared language. Why is this so important? Now that gets me into a lot of the other books that I've been reading these days about philosophy, because that shared model that we have in our heads that we developed with our careful participatory sense-making exercises, sometimes we represent that model in a UML diagram with boxes and lines. Sometimes we represent it in code with careful naming. We might have a glossary or the documentation. Those are representations of some aspects of the model. They are not the model. The model is the thing between our heads that we collectively understand in our brains. Is that a real thing? Well, the answer to that goes to my favorite philosopher, Karl Popper. And this is like very recent Popper, like 1978, not long before he died. He published a great lecture about his three worlds hypothesis. He views reality as broken into three worlds or realms, which he names World 1, World 2, and World 3, because he did not have a better name for them. But World 1 is physical reality. It's the objects that we can touch and share. It's also like magnetic fields that we can all verify and measure together. World 2 is human experience, is feelings. We can't share that. We each have our own. In this way, we are always alone. But World 3 is the stuff that we can share, starting with language. This is the stuff that we share between and among our mental spaces. And these World 3 objects, things like economy, money, justice, law, Captain Rar, before he's physical, the spell itself. I mean, we may write the spell down in the spell book, but the spell itself is a concept. These are World 3 objects, and they are real. You can tell they are real because they have a causal effect on the world, on the World 1, the physical world. So you can notice their effects. Money, for instance, determines who eats and who doesn't, determines which buildings get built and which ones go to rot. Money may be represented physically with cash, but the real concept that has causal power is shared between our societal agreements. The spell may be represented in the tome of spells, but it is something different. And we share that as spell writers. It's the same with our software model. Now, our software design is one of these World 3 objects, this model in our heads, but it totally affects the physical world because we put it in the software and then the computer executes it and then different things appear on screens. And if something different appears on all my screens than all yours, if you're seeing completely different news stories than I am, we live in different worlds, man. And that has a causal effect. Cesar Hidalgo, in his book, Why Information Grows, talks about this, how a product is embodied knowledge. So a pencil embodies like how to dig up graphite. And I just get to use it. I just get to decide what to write with it. Software totally encapsulates knowledge. I mean, our spell encapsulates how to construct and fit together a creature. But like Uber and Lyft encapsulate how to get a car to show up at my house. It's wonderful. Amazon encapsulates all kinds of knowledge about how to find products and then get them delivered to my house. Also amazing. But knowledge is our limitation in this book, and we can only fit so much in a single person. That's why we have teams. And among our teams, we have to work really hard at getting our World 3 objects to coincide. And we can only be precise about them within a bounded context because everyone's knowledge is limited. Skip, scoop. which gets back to Karl Popper, a very young Karl Popper, who pointed out that arguing over definitions is useless. The meaning of a word is its use. And if you don't control the use, you don't control the meaning. You don't get to decide what the word agile means. Sorry, it means whatever people use it for, which means nothing now. But Josh will tell you later what it really should be. But that's all historical. However, within a context, agreeing on definitions is priceless because we do influence the use of words within our teams. We do control what goes into our software. And that's how we can really smooth communication, and we can work as one team. We can operate together, and then we can put it in the software. And this is how our spells come together, and we put it into that bubbling cauldron, and we create monsters. Or in software, we create the ability for me to pick up my phone and wiggle my finger in a certain way, and toothpaste shows up. Or I wiggle my finger in a certain way, and a message gets sent across the world. It's amazing. Software development is reality construction. We really change what is in the world. And when we're deciding what is the world going to be, we do that together through our participatory sense making. And this is something, this book, Linguistic Bodies, very modern philosophy. This was published in 2018. Can't recommend it. It's really painful to read. But the concepts, there's a paper linked that's better. The concepts are really important because participatory sense making isn't something we do in software. There's no software in this book. It's something we do as people. It's something we consciously do in our relationships. This is how we form relationships and families. It's how we agree on what's real in the world, more than just physical reality, although that too. But also all of these world 3 objects that says what is important, how should we act? This is all through participatory sense making. And in software, we really see the effects of being good at participatory sense making. I think that's why there's movements in software toward empathy, toward inclusion, toward being able to bring as much of yourself as you want to work, so that we can add these perspectives, so that we can create something that fits in the real world and not just in downtown San Francisco. So in software, we have reasons to get good at participatory sense making. But when we do this, we're also getting better at being people. And in the meantime, we can take our shared model of a monster, put it in the runtime of the bubbling cauldron, and make it real at defending castles. I mean, if I were these adventurers, I would be terrified as soon as that stereo switched on. And that is something new in the world. And when we see our software in the world, we can learn from it. And when we do, we strengthen our symathesy. So a software development team is a symathesy. That means a learning system made of learning parts. We never hold still long enough for you to understand everything about how it works. Constantly learning and growing and strengthening that learning and our collective sense-making skills strengthens our symathesy and lets us make new reality in the world. This is our magic. Thank you. I would like to thank Frabas Magic Fantastical Creatures Company, and of course, YOW and Skills Matter. If you'd like to see more, the references on this post are at jessatron.com/DDD. You can follow me on Twitter at Jessatron, which has disappeared from this slide. Also, if you want to talk observability or really anything, you can schedule time with me at honeycomb.io/office hours. I would love to talk to you more. Thank you.
Wow, Jess, that's all I have to say. You took us on a whirlwind journey. I'm not even sure which way is up right now.
It was a lot.
It was, honestly, and I've never worked for Frobos Magic before, so that was a great little journey out as well. But everyone in the audience, if you've got any questions, pop it in the Q&A tab. We've been great on the chat tab and it's been so much fun, but pop your questions up in the Q&A tab. And I'm going to start, excuse me as I read to the side because that's where my other screen is, but we're going to start working through some of those. Here's a great one. Oh, someone upvoted mine, but we can do mine last because that's a bit selfish. how do we detect and adjust for bias in the sense making? And I think this ties into a comment in the chat, which is around how are we accounting for the people who aren't in the room at the same time?
Beautiful. Right? Right. I mean, that's of course why we try to get a bunch of diverse people into the room and speaking and feeling like their voice is valued. But I like that the question included the phrase, how do we correct and something else, but how do we correct for bias? Not how do we eliminate it? Because we absolutely do not eliminate it. Please do not try to reduce bias by removing human judgment from the process. That just encodes the bias. I mean, constantly go back and check production in this case to see who is using your software. And if you don't have a diverse group of users, why? Talk to people. Talk to the people who you want to benefit from this product. So if you make software for low-income people, do you have any people in your circle who really need that? Are your developers in your target market? Kind of inherently not. As a developer, you're probably not low income, but maybe your parents are. And can you actively put developers in touch? Can you get out into the community talking to the people who are your audience and to the people who are not in the room?
I love that. You can bring.
So it's a lot of work. It's just a lot of work, but we can adjust for bias. We can add to what we're doing to enhance the richness, to incorporate more of the real world that we want to fit in.
And it makes better products, right? Like at the end of the day, if your product is designed for the end user, everyone's winning a little bit more.
It's tricky because we really want to go for the low-hanging fruit, right? We really want to serve the wide market. And if we're serving 80% of the market, then we're going to have product market fit and we're going to be able to make money and it's going to be enough. And if all you want to do is make money, okay, whatever. I mean, you can make money in downtown San Francisco. But if you want to really make change in the world, it's that 20%. It's the rest of them, especially for inclusion. It's inherently about the rest of them. It's never going to be the low-hanging fruit. It's about the fruit that's hard to reach. So get your ladders out and climb and try harder.
That is such a great way to frame it. I love that. It was just a mic drop all in itself. One of our very first questions as we were running through this was, and Michelle suggested maybe there's a union for magical creatures that needs to be developed. But as we develop this, how are we thinking about the ethics and the rights of these creatures that we're creating from the void?
Fortunately, in my analogy, the creatures represent software, and I'm not really worried about its feelings. But I do want to know about how it's affecting the adventurers, and is it like slaying them when it's supposed to be just deterring them or something like that? So we can care about how our software is affecting its customers. I think observability helps a lot with this, not just monitoring, but injecting into your code events that tell you when someone got an error message, that tell you when they got a validation message and couldn't continue, or when something happened that they didn't want to, and they're like, cancel, cancel, cancel. Can we find out what's happening in production and see if those are the consequences we wanted to have?
I love that. Observability is just a crucial point, and I don't think we do it enough. I mean, this is just a broad statement. I don't believe we do it enough in the industry. So I love that you brought that to the forefront.
Yeah, that's a word that's also being used to mean things that don't fit its original meaning. It doesn't mean monitoring. It doesn't mean graphs. Originally, I want observability to mean your software teaches you what's going on inside it. And it'll only do that if we teach it how, because that's our job.
And use it in that manner as opposed to just logging of things.
Oh yeah. Yeah, it's its own thing, but I don't want to get off on that.
Yeah, sorry.
I could talk about observability for a long time. It's why I work for Honeycomb, because I think it's really important.
So important. So we get to go to my personal question now, which is around what you said is so important, and there's so much in it. How do I, in my organization, just start implementing some of these amazing things you talked about?
Excellent question. Okay.
Yes.
Yes. Number one action item that you can do today, get precise with your language and push the team to get precise with your language. The newer you are to the team, the better you can do this, because you won't notice it in yourself at first. So try to notice it in other people. When somebody says, oh yeah, download that library over there, and somebody else calls it an app or a distribution or something, be like, okay, which is it? What is this thing? And like drill down into those meanings. And people, once you push on it, people can define the things, but we're typically really sloppy with our language, especially within our teams when we're comfortable. And being precise with our language is going to make us even more comfortable and even more effective.
That is such a great actual practical step about what to do, because I come away from talks and I'm like, yes, I'm going to go back and change the world. And then I go back to work and go, but how? So,
right. Thank you for asking that.
And I love your shout out to the newer people on the team, because you're right. They have a whole other visibility that you don't have when you've been there for a while.
Yeah, when you don't understand something, that is precious. I mean, that is a precious piece of input to the rest of the team that they are not speaking clearly, that they have not defined their terms. And that's how we find inconsistencies. That's how we get better at communicating, is by grasping those opportunities of confusion.
I love it. And it's another great reason to hire juniors as well. I would put out to the universe.
That's true. It pushes you to more explicitly talk about what you're doing, and not, and also diverse people. I mean, it is easier to work with people who are just like you, who understand all the same metaphors because you all played the same video games growing up. That is easier and it is efficient to a point. But then you only get so far. You only get that low-hanging fruit, and you never get precise enough in your language to bring other people onto the team, to split the software and have multiple teams start working on separate capabilities and evolving. That precision comes with the pain of coping with diverse perspectives, coping with having to come up with new metaphors and more careful language to explain stuff to somebody who didn't grow up on this effectively the same street you did.